Okay, so that was the problem. Basically, I forgot to add the HTTP at the end and the get, because otherwise it gets rather hell yeah confused as to what the fuck you're trying to do. Okay, so let's just close this down and restart it again. And now that should work. Oh, you got the camera. Yeah, that's why sometimes these things can be really annoying. Is you don't get one moved in right and then you have to rewrite the code. So let's try it again. There we go. Okay, so now what we need to do is, if I'm correct, I believe we need to take note of where the EIP points to and the ESP points to. So what we need to do is load up the pattern offset RE tool. So if I go back here, skip past all of this beautiful shellcode. Not. Just kidding. Will be shellcode pretty soon. Pattern offset RE. Okay, so now what we need to do is take the information that we found and find the offset. So this may be different for you than it is for me. So for this just takes the first 7 bytes. First 4 bytes, so this would be H7CH. No, sorry. Whatever. Just take the first 4 little characters here and paste them in. So here would be H7CH. Okay, so again, offset of 1792 for my ESP, and for my EIP, if I copy, let's see what they're doing. Yeah, I've got to copy the whole entire address. So this would be 43366.843. So those are my offsets. EIP is offset at a distance of 1788. ESP is offset at 1792. Okay, so continuing on. We now need to double check that these locations are correct. So what we're going to do is we're going to basically, what he does here is this is all padding. So this is basically going to create a whole bunch of knob space. Knob space is basically solve for no instruction. So essentially it just wastes CPU cycles, which is actually a good thing in our case, because basically this is filling up the extra space that we need before we get to the, because this is offset at 1787. Now if we write those first 1787 addresses with 90, then when the next address that we write should be the location where EIP is. So if we write it with this address, then this address should be put into EIP. Okay, the next thing it does is we want to go up to 1791. That's what we want our buffer to be at this location. And we want to basically, take the length of the buffer and minus that. So we want to find the difference between the amount of bytes that we want to write and the total length of the buffer currently. And then fill in that space with more knobs as pattern. Before we get to the exact location of ESP, and we want to fill the rest of the buffer, which is 220 minus the current length of the buffer, with CC, which is basically short for interrupts. And this, when detected by the debugger, will interrupt the program, so you can see what's going on. Okay, so now I need to basically edit my exploit to do that. So if I come back over here and go back to my exploit and delete all of this. Oops, might be better to just do that. Okay, so now we need to add, what did we get? We got, oops, one. Okay, so this is, now we need to overwrite it first with the offset from ESP, so we need to write the amount of knobs times the offset from ESP, sorry, set that wrong. So 17 equals 1788. Oops, actually it's the other way around, my bad. 90 times the offset, which is 1788, and the buffer, and then we need to do the address that we want to override the IP with, plus equals, and then the string of A's, all of them, so 4 lots of 41, and then we want to take the rest of that buffer, so up to my other offset address, which is 1792, so plus equals 1792, I think it is. Yeah, actually, no, I am wrong yet again. I need to do it the other way around. That's slash x there, times it by the offset from EIP that we found. Sorry, actually, that's, wait, this is ESP, this is EIP, right. Okay, so then we need to do that, and do 1792 minus the length of buffer, and then buffer. Need to fill the rest with C, so, interrupts. Wow. Okay, so times the rest of the buffer, which is 2220, if you remember correctly. Buffer, and that should work. So now we're going to save this. And go back and restart, which is, as you probably know, this button up here. Yes. Now I want to run it again. And trigger the exploit again. Now what we should find, if we look down here, is that we should have a crash now points exactly to this address, and ESP points to the beginning of this CC or interrupt buffer. Okay, let's double check that. Yep, points exactly to the start of that interrupt buffer, and ERP points to the 41 that we expected. Okay, so now that we know the exact locations, we need to find a way to get shellcode into there. So let's try and overwrite the address with the EIP with the address that we found earlier, which is the jump ESP address. So we're still going to need this so that we place this address exactly into the IP, but instead of doing the other funky stuff with the little buffer here to get exactly into ESP, we're just going to overwrite the rest with interrupts so that we can stop the program. So if I can fix that up, I'm going to basically delete this line and instead replace this with the address that I found earlier. I'm just going to quickly search for that again. Control find, jump ESP. Now what we're going to do is we need to write this in little endian order, because most intels are little endian. Basically what you do is you take this address 7C A558.26.5, and basically what we do is we take each byte and write it backwards. So a byte in this case would be 65, so the first address, the first little byte that we're going to write, sorry, it's going to be 65. Then we move on to the next one. Okay, what's after 65? We then have 82. So we write that into the next part of our address. What's after that? Looks like A5. So we write that in. And then what's after that? 7C. So we write that in. Okay, let's just check I'm still recording. Yep, I'm still recording. Okay, so now we're going to save this. And we're going to go ahead and restart this and see if we can jump to where we're going. However, before we do that, what we want to do is we actually want to place a breakpoint on that exact location that we found earlier. This will tell us, a breakpoint basically stops the program when it reaches that point. So if we press F2 at the address, we'll toggle a breakpoint. And as I was going to explain, basically when you reach this, when the computer reaches this point in memory while it's executing the program, it's basically going to stop there, halt, and say, okay, I've reached this point, now what do you want me to do? Do you want me to continue? Do you want to edit this or that, etc., etc.? Okay, so now I'm just going to trigger the exploit and scroll down. Yeah, so now we should have it paused at the breakpoint specified. And the next part is the most exciting part, adding shellcode. So first, let's just make sure this works. Yep, I hit the breakpoint, and just hit F9 if you want to continue running the program. Yeah, and as you can see, it hits the first part of our interrupts. Okay, so let's just restart this for the sake of restarting it. Okay, so the next part we want to do is something called Metasploit framework payload. And basically what this will do is generate a payload for us. So if I go up here, clear this mess up, and go Metasploit framework payload. Now what we want to do is, you can also use Metasploit framework payload -h. It will basically list all the payloads for you. I'm not going to use the one they use simply because it just doesn't work for me. So instead what I'm going to do is use Windows/shell_TCP, and I'm going to put, actually give me a sec and I'll be right back.